everyone, so today we're going to be learning about discrete random variable transformations. So the whole point of discrete random variable transformations is when we're given a PMF of a random variable, x, and we are also given a transformation, y, we want to figure out the PMF of y given our PMF of x and our transformation y. And to do this, we first need to figure out if our given transformation y is 1-to-1. If it is 1-to-1, that means we can use this set of steps over here to figure out our PMF of y. If it is not 1-to-1, we will have to do this case by case. So this video is about the 1-to-1 case. So this step over here is telling us that our PMF of y is equal to our PMF of x when we input the inverse of our transformation into it. So our inverse of our transformation is just when we're given y of a function of x, we just solve for our x and we just plug it into our PMF of x. And this will give us our PMF of y. So let's do this with an example. This example is taken from textbook question 1.6.8 from the Introduction to Mathematical Statistics textbook by Robert Hogg. So this question says that we have a PMF of a random variable x. This is our PMF and this is its support. And we want to find the PMF of y equals x cubed. So to do this, our first step is to figure out if y equals x cubed is 1-to-1. And clearly, y equals x cubed is 1-to-1. You can determine this by the graph. So y equals x cubed looks something like this. And if I draw horizontal lines, it goes through it once. So it passes the horizontal line test, therefore it is a 1-to-1 function. Since y equals x cubed is a 1-to-1 function, that means we can use the series of steps over here to figure out our PMF of y. So let's do these steps. I'm going to set the PMF of y equals to p of y equals to little y, which equals to p of x cubed equals to y. This is our transformation. Now we just need to solve for x. We need to find the inverse of this function. So we're going to make this p of x is equal to the cube root of y. And now we're going to set this equal to the PMF of x with the cube root of y inputted into it. Now we take our PMF of x, which in this case is 1/2 to the power of x, and we just plug in the cube root of y in for x. So this is the same thing as 1/2 to the power of the cube root of y. Now we're still not done finding our PMF of y because we need to find the support of y. So to find the support of y, we're going to be using the support of x. This is very simple. We're just going to take the support of x and plug it into our transformation. So for example, we first start off with the number 1. We plug in 1 into y equals x cubed. So we do 1 to the power of 3, which equals 1. So that means our support of y has the number 1. Then we do the same thing with the number 2. We do 2 to the power of 3, which equals 8. So now we have an 8 in our support. We're going to do the same thing with the number 3. We're going to do 3 to the power of 3, which equals 27. And this goes on for infinity. So this means that our PMF of y given the PMF of x is this.